Hello, YouTubers. This is another session where we'll continue our OData Neo discussions and development. We took a little bit of break. There was a bunch of vacations and time off and, other conflicting meeting. But now we're back and we'll be able to continue our, series. And I'm joined today by my dear brother, Sam. Shoot, Sam, you're very popular on the internet these days. What are we going to do about that?
Popular at the internet?
Yeah, you're a popular guy. You're very famous.
Really?
Yeah, of course. You're helping people everywhere. People really love what you're doing, brother. Of course.
Oh,
Here we go. Here. Oh my God, what? Oh, how are you doing? So
oh, you mute.
it's a little 9:30 today, so hopefully things will be a little bit quieter on your side. Paul, you're on mute. Did I mute?
Nah, you're hoping, mate. You're
You're up.
hoping.
Oh, I'm just hoping. Okay, sounds good. Sounds good.
There you
Up,
go.
there you go. That answers the question. It's pretty cool. Anyways, okay, so where were we last time? Last time we talked a little bit about, fixing our test a little bit. So instead of actually having to generate the raw query, we could just generate the result, again, using the law of axioms where you just go backwards from the end results back to the query and then give it back to the method and have it doing the opposite of that. And I think the person that had that in their hand, I don't know, someone from England somewhere, I don't know. Is that Paul? Paul. Oh, Paul is talking while on mute. Or maybe he's just telling their kids off, telling them off.
Yeah, he is talking to his kids.
Paul, do you want to share and care and show us where things at?
Yeah, if you'd like to listen to my girls for 10 minutes, that would be great. Yeah. They've got a lot to say.
Paul, how many kids do you have? How many kids do you have?
A lot.
Quite a
I've got a
bit.
1 year
I'm
old and a
thinking
4 year
nine.
old. So,
Oh, just
yeah,
just just
they
two.
sound like a
They
crowd when they're
sound like a
going.
they did definitely. Can
Certainly
you
not.
can you
Not easy.
imagine Paul just sitting with his kids and answering the phone and his manager calling saying, "Where are you at?" And be like, "I'm at home." It's like, "I don't believe you. I can hear a crowd around you." You must be at a stadium or something. Oh, Paul, do you like Manchester United or Arsenal?
No, no,
No. Just
neither.
just no. I love that answer.
Just,
That just
just
tells me.
no. Yeah,
What are you, Chelsea or
I'm a programmer.
Because I like Manchester United.
Manchester United? Everyone likes the Red Devils, the Manchester United. What about Liverpool? I got one of my own countrymen playing over there. You guys know him? Mohamed Salah.
Mohamed Salah.
People go crazy. I like Mane as well. I think he's pretty cool. Paul is like, I don't know any of these people. The very
I don't
the
really follow the
only
football.
Englishman that will ever see in my life that doesn't follow football. It's called soccer, Paul. Just
Soccer.
letting you know. It's soccer.
Nah,
Hello, we're speaking English here.
nah.
Okay.
It seems Paul is only a software program
He's
I'm
just a
only
software
interested in
program.
proper
developer.
English.
Yep, he's only interested in proper English. That's it.
Yeah.
Okay, let's jump into the code, guys. Paul, can you share your screen? Let's just see what's going on your side.
Uh, oh God.
Do you have the code?
I
I think he
don't have it
deleted
loaded.
everything.
But give me a second. I've got like 10 Visual Studio windows open. I've
So,
literally
so
just
I
come
gave you
straight.
30 minutes heads up to open up Visual Studio.
You just don't like me, do you? That's all it is.
Paul just
It's all it must
Paul.
be to put a shirt on.
Yeah.
At least he put a shirt on. That's right.
What are you trying to say? I made the effort. What would you want?
You put a shirt on. You got your
I mean,
hair done somehow.
This is how my hair comes out when I get out of the shower. It's just,
I am so jealous, man. Takes an entire army to get my hair in that Bob Marley state that I'm in right now. So we're making progress. All right, I'm looking at the code. I'm seeing while and if else, and my heart hurts a little. But anyway,
hang on.
let's. So where? So what?
So
What?
I
Okay.
can't remember where I got to with this, but I was tinkering with. Okay, so there's stuff in here that we haven't discussed on stream, but basically, where we were going last week, we were talking about a potential interim stage that involved O tokens. So the idea was that we have our OData string, okay? Our string then needs to be broken up, is kind of where we were going, into tokens, which could still be a flat list. So you'd have your list of tokens. And then from the list of tokens, you could then build out your hierarchical model, was kind of like where we were sort of going with things.
That's right.
Now, we didn't really kind of fully flesh out how that was going to happen. So what I started doing was tinkering with this idea. And Sam very helpfully sent me a link to this in the existing OData repository where he does exactly this task. And I realized the sheer scale of the problem that I hadn't addressed, essentially, with this very dumbed down sort of start point. So I thought,
why do you
the
think
best...
he's smirking at us half of the time? He knows that there's this thing, and we're just looking in this thing, and he's like, okay, just let them play a little bit and see where this is going. Go ahead, Paul.
Let them suffer first, and then he can step in and go, I've solved all this. So so basically Sam did exactly that. But long story short, we started that kind of down this road, but what I didn't want to do was kind of go too far into the exercise without there being this kind of live stream where we kind of talk about it and kind of decide where we're going to go with it all. So
that's right.
What I thought was probably best to do was just to sort of put down what I had and then pick up from now, essentially. Now, I think Joe had some good ideas as well about using, from a testing point of view, using some finites rather than random, so that we could have a known set, if you like, of constants, essentially, from a testing point of view. So there are known things like the operands, for example, right? Equality, greater than, less than. You can see on line 20 here. I kind of threw a list of them together. That's probably not exhaustive. Can you read that, Sam?
It's very small.
Okay. It's
better.
Now we can see it.
So okay. Essentially, where I was going with it was the tokenization service stopped being the thing that created models and started being the thing that would create an array of O tokens. I used an array rather than a list because my thinking was, once you've got a token array, that is a direct representation of your OData string. So it's not a thing that's flexible in size like a list would be, right? So it makes more sense for it to be a fixed size collection.
I like that.
So it's a list while I'm building it, but then once tokenize is finished, it becomes an array.
That's right.
Yeah. So what I started doing was like building out helper functions that would determine kind of, certain cases, but actually looking through what Sam's got on the current live version of OData, it's a lot more involved and involves essentially a large switch block that was able to kind of tokenize out for each possible token that could be in a URL, essentially.
See, that we need to kind of think about. I know that this is what's in there. I know just for the people watching us, if you look at the previous recordings on OData, you'll see this. He walked through the entire. Remember, Sam, when you and I kind of, last year we started going through the current implementation of OData as it stands. Sam,
it's a lot of it.
where did he go? Sam, are you with me?
Yeah, I try to remember.
Okay, so here's the thing, Paul. Can I grab your screen for a second?
Sure.
Where is my life?
Wow, that's a complicated question.
What's so wrong about just being a greeter at Walmart? What's so wrong with that? Huh? You get to do this on the slip. The paste. That's it. What's so wrong about that? Okay, here's the thing, Paul. let's just bring ourselves back into focus because this is really important. In order for this project to succeed, we have to kind of stick to our
So are we
our
going back into Lakehouse mode? Yeah.
no, just hear me out. What are you doing? What are you doing?
What are you doing? What are you doing?
We're building a bunch of services that will eventually not be dependent on each other, but rather dependent on a lake house.
Yeah.
But don't worry about that now. This is like high level, architecture. We're a little bit, we want to talk about, what we're trying to do conceptually first, right? So we talked about the tokenization. I'm okay with that. You have a tokenization service, and this service will produce a thing, and this thing will be just a list of tokens. So this is our token array, like Paul just indicated.
Yeah.
Now, what happens after that is very, very important. We need something smart that will pick this up and turn it into a hierarchical list of nodes.
So what
And
I came up with was a model building service or a model builder of some description. So what that would essentially do is, as an input, it would take a token array, and as an output, it would give you an O node.
yep, I agree with that. On-node service, or model building service, whatever you want to call it. This service, however, this is where the plug and play happens, right? Because this list of token, it's gonna go and say, who in here, who shall we send and who will go for us, right? So I'm gonna put a bunch of these in here, and it will go and say each and every one of these services in here will be concerned with a particular convention within the tokens that are coming in. So this, for instance, will be the select service. This will be
So
the filter.
we have to be careful at this point.
Yes, go ahead.
Because tokens now start to have a real meaning.
Yes,
And so we're less talking about tokens and we're more talking about node structures.
yes. We
So
already
a convention will handle
Mhm.
one or more nodes with a given structural pattern to them, essentially, or will be a definition of, and then a service will handle
Mhm.
one or more conventions in terms of what it processes. That's my understanding.
I understand that too. What I'm trying to say is that your own node service will take these list of tokens and it
Yeah.
will go find based on the operator. Is that what we called it, Paul? Operator, the select, expand, all of these things. We called these operators, yes?
So my understanding are that they're the
Node type.
parameters.
The parameter or node type?
So a dollar select in an OData query is a select parameter.
But what's the node? But what's the node type that holds that? What's it called?
I would think it's a parameter, isn't it?
I don't think it's a parameter. We didn't call
So
it
if
a
you had
parameter.
something like filter, and then you had like name, EQ, and then some value, right? So filter would be a parameter. Name would
Didn't
be
you say
a
clause
property.
or something like that?
So
Let me look at the code. Let me look at the code. You have the code still open, Paul. Just share your.
I believe I do. Yeah.
Just open it up. I'll flip to your screen real quick. You don't have to.
We call it a parameter.
We called it a parameter. Go to the node type real quick. Node type.
So if we go to.
Gosh dang it with your 40K nonsense.
Sorry, I've got a screen.
Go inside node type. Go inside node type. Oh, parameter. You're right.
Yeah, so we refer to them as parameters. So what we were doing is we would build a node for the parameter and then a number of property nodes, essentially.
So you're calling it parameter like a query parameter, a URL query parameter.
Yeah, essentially. Think of it in the same way that we would think of a traditional query in a URL, right? So you're taking the bit after your question mark and you're saying, okay, I'm going to process that. And that is essentially a list of parameters with values. But from an OData point of view, those values need to be further broken down and tokenized and then turned into nodes within our model, right?
Perfect. So stay with me on this one, okay? I'm going to go back to this screen here.
Okay.
Based on the parameter, this O-node service will determine which service it needs to pull in to process a certain block based on the parameter that is working with. And it doesn't pass it down. It's pulling the service capability to process that particular parameter. What that
So
basically...
there's a step between the token array and what I think you're describing now. So the node service, the way that you're describing it is the node service is essentially an orchestration service that orchestrates between different, if you like, convention handlers. So between having your token array spat out by your tokenization service
you're right,
and
Paul.
having your node service, you need your
You're
model
right.
builder.
Yep, you're absolutely right. So this is node service, and we're gonna have in here something called query orchestration service.
Yeah, that would make sense.
I like that, Paul. Works.
So then you go from having a token array to a node, essentially a root node, which you give to your query orchestration service. So
Yep.
you can
It just starts. Yep. The outcome of this, as it leverages all of that, it will spit out whatever you want it to be. It could be an expression, it could be another string array, it could be whatever it needs to be. I love that architecture, because now you can go and say, now imagine this being a Lakehouse pattern. So you see all these components that we have right here. Oop, not this one. Imagine this guy here. What is it? What?
You want to see that one?
Oh, not that one. That's different. So imagine this very same structure. This is the new thing that I'm adding to this project, is that we're gonna go here and we say, here's a lake house, here's a substrate, like this, where these components are sending technically events and messages to each other, more like events. And I'm gonna take this guy, this guy, this guy, this guy, and this guy, and this guy, and this guy, and I'm gonna go here. And I'm gonna spit all of this. Is the new thing. This is the exciting thing about this project, not just moving some queries around and doing, and you're putting all of these together next to each other like this, and they're listening to particular messages and particular events in your system. So they know that it's them that are targeted, that they need to process that. What that basically means, you guys, is that at any point in time, we're giving the engineers the flexibility to decommission any of these components and install any of their own components, and they still communicating with each other without having to know anything about each other. This Lakehouse pattern is taking dependency injection to a whole new level. You're literally separating the components so far from each other. The only thing that's left for me to detach is the contract. And I'm still thinking about that. So there's 3 levels of dependency between components, right? The first level is the method that you're working with, the function. We killed that. With this lake house, we already killed that. I don't have to know about who my dependency is. I don't have to call the function. The last thing is the contract. And I don't know how to solve for that yet, but hopefully during the process of OData Neo, I'll figure out a way to kill the contract. I have an idea using dynamic objects and stuff like that, but it's a little risque at this point. So let's just take it easy, right? But if we agree on this flow, I am very happy with that. And I think we're still here, Paul, right? We're still at this point here where we're going at this, how I measure like progress on any project, right? I think what we're trying to do is to basically just write a simple, write a test that basically receives a randomized token with nested children and all that in it, and it turns it into a query, and then we spit that from the other side as a query.
So actually we can start even simpler than that, right? Because from the point of view of like URIs and what they look like, there is a fixed number of possible tokens. So we can essentially write a test that confirms for every one of those fixed possible tokens that we get the correct token type out. So when I define
what do you mean? What do you mean?
So if you think about a URI, right? So you've got, let's say I've got,
select or order
question
by
mark $filter equals name space EQ space quotes some value. right?
Mm-hmm.
So I've
Mm-hmm.
got something like that. Okay.
Mm-hmm.
So the first thing I should get, my first token should be $filter. And it should say, hey, this is your first token. This is a parameter and its value is $filter, right? Then the second token should be, well, we got an equal sign here, so equality, which is another token type essentially. Then the third token should be, it's a property token because I'm pointing at a property, right?
Mm-hmm.
So it should say, okay, it's a property token and its value is name. And then
So you're talking validations.
no, I'm purely talking essentially a smart string split at this point. So I'm saying, hey, when I split this string up, I need to confirm through testing that I split this string up correctly. And I recognize that, say, $filter is a token and the equal sign is a token, but they are not turned into one token or 6 tokens.
Okay.
See what I'm getting at?
Okay, gotcha.
So
Yeah, we can definitely do that. I'm
that
okay
level
with
of testing we can do very concretely without any kind of randomness associated with it. So we can be absolutely certain that, given a very solid fixed input, we get a very solid fixed output. So all of that complexity around random testing goes away. However, following that, we would then run our random tests and say, hey, given some random string, given that we know how our token array is going to come out as well, because all of our token tests are passing, we can then be more concrete about, okay, if I've got, say, a token array, I know what I should expect from the point of view of a node, for example, an O node that should be built from that token array, because we can write some logic into our tests that says, okay, I'm going to construct a token array and I'm going to turn that into a model in my test. And then I'm going to pass that to the service and make sure that the service produces the same model.
But wait, Paul. You're basically saying, but you're adding convention here into your tokenization service, right? You're basically going and saying, I know for a fact that filter is gonna have 3 things after it, which is name equal Paul,
No,
right?
no. I'm
Oh.
saying I've got filter. I've got
Mhm.
$filter at the start of my string. Okay.
Mhm.
I know that is a parameter because
Yes.
it's an alphanumeric string of characters with a preceding $. So I know that from an OData point of view, OData sees that as a parameter.
That's right.
Yeah.
That's right.
I've then got an equality sign, which tells
Mhm.
me, okay, I've now defined what my parameter name is, and I'm going to tell you what the value for it is. So this is the equality symbol that says this parameter has this value.
Mhm.
Yeah. Okay. So then the next token that I've got are the things that make up my parameter value. Now, I can make certain assumptions about what those things are, or I can say, hey, these are just things within, the parameter's value in some way. So I made an assertion by saying, hey, everything that's in there is either going to be a property, some white space, an operand, or a value. Does that make sense? So at this point, you could argue, yeah, you might need to have an understanding of convention at this point, or you could have tokenization not understand those conventions and
Let's not.
Okay. So
Why?
tokens
Why
then
though?
don't need to understand the difference between, say, a property and a value. They just need to say, hey, I've got a value, or I've got white space, or I've got, say, an operand. Because operands we would know about, right? There's a finite set of them.
If it maps everything that is preceded with a $sign into a parameter, and maps everything that is constant as constant, and maps everything that's operand as operand, I'm happy. And ignores every equal sign, then I'm happy.
And the other thing I would say is make it so that operands is an array that's exposed somewhere by the framework, such that it's like a string array. And so if users want to extend the operand list, they can. So we might put EQ in there, but somebody might want to put, EQ
Whatever,
when
NG or XOR, whatever. Yeah.
XOR. That might be an interesting example, actually. Yeah. So if somebody does that, then that, when I do my tokenization, comes out as an operand token.
Why the tokenization service needs to know about that?
where we were going with this is we came to the conclusion. Well, I don't know if we actually came to the conclusion, but what we were saying was that we were going from having a string to having this kind of hierarchical O node, and it might be that we were going too far, and that actually what we needed was this interim step so that we could analyze and get more detail out and understand the reasons why we had that node structure in the first place. It was felt, I think it was Nick and I think Joe to some extent.
Where's that guy at? He's not coming today? Okay, sounds good. Let's keep going, Paul. Sorry.
Yeah, the other guy. He's not important.
Before we get much
further,
go ahead.
We
sorry, Joe.
have two other types, which would be open and closed nesting.
Yeah. So when I started going,
that's how you determine children. That's right. I'm sorry. Go ahead.
Yeah. So when I started going down this route, as I was saying earlier, Sam threw me at this exact same code block in the existing OData framework. And it's interesting, actually, because there's probably about 100 scenarios that none of us have mentioned throughout the entirety of this series, just on the possibilities of all the tokens. So my reasoning behind going down this route in particular is that it would make us think about what is actually in the contents of a URL in a very concrete fashion. Instead of us just saying, hey, I've got some string of characters, and now I've got an O model, I can say, hey, I've got some string of characters, and those characters should look like, in terms of what these pieces are, something concrete. And we can define things like that. Didn't Nick say that he was not here today?
Yeah, don't worry. It's probably traveling. Yeah.
So yeah, things like if you've got an open brace, or if you've got a square bracket, you can say, hey, this is signification of, I'm starting an array declaration or something, But I can concretely define, hey, that character means something. If I've got some white space, I can say, hey, this is white space. I've identified this in my tokenization process, that there is white space in my URL. What I felt we were missing when we were going straight from the string to O node is we were picking bits out that we thought were relevant, and we were leaving other bits that we didn't think were relevant. But actually, when it came down to testing our O nodes, if you think about it, our input would be some random string that we generate, and our output, if we serialized that O node, would not be the same unless we inferred certain things. So this interim step of having an array of tokens, the array of tokens would be explicit and contain all of that information, where the O node array might or might not, depending on whether or not we deem that information important at that level. Am I making sense here?
Yeah, I see what you're saying. Hold on, Paul, just because, I know what you're saying. I think, a lot of people know what you're saying, but I want also people watching.
So Paul's comment is like every string in the URL has its meaning, right? It's not only the string.
Keep going, Sam. I'm listening.
So here it means name is a string. Sam is also a string, but the name is typically for OData is a property name.
Yes.
And Sam here it's a single quoted. It means a string literal.
Yeah.
So it's a different meaning.
Yes.
And $filter and $select is a keyword for that. It has a special meaning.
Yeah. So we have parameters.
Yeah, so from parameter,
like filter and select in this case, right? And you have constants, and these constants are two types. Like you say, Sam, it doesn't matter because you're gonna put it as is. So that would be Sam, like this, and also name. These are constants, right, guys?
Well, that was an interesting question, because when we were talking about it earlier, you were saying about at this level, do we need to have an understanding of conventions? And if we don't have an understanding of conventions at this level, we might want to just say, hey, all constants are potentially just values at the moment.
I'm okay with saying values as well. I just think that somehow we need to distinguish between.
Wouldn't be a constant. That would be probably a property reference or something for the select equals. I wouldn't list that as a constant.
What would you call it, Joe? A property?
Yeah. Well, on the right hand of the operand, it's a kind of like a reference.
Just a
So there's
reference?
there's an interesting point to be made here, is that like on the filter, you know,
What's the meaning of the question mark?
got my train of thought.
Question mark may be basically saying, do we need a fourth type to indicate what age would be? What's age? So Joe is saying maybe reference.
And property,
I'm leaning towards property, Joe.
Yeah.
Yeah.
Can you argue for reference?
Not without bringing in the other parts of the system.
Okay. Okay.
But you can see here at this point, we're already inferring convention. We're saying, hey, we know what this looks like from a human perspective. We're parsing this query and we're breaking the pieces out, and we're saying, hey, based on my understanding, name and age are both property names, right? On some object. So we're saying, hey, what this represents is some question on an object model. So we're already inferring, hey, look, there's a class here with, you know, a name and an age property on it.
Yeah,
I wanna avoid that. Go ahead.
Yeah,
Go ahead,
another
Sam.
part is we don't know the EQ. What's the meaning of the EQ?
It's
So from the tokenization service, it's only know it's a name. It's a name is a word. EQ is another word. SAM is a word. Age is a word. There's no meaning about the what's the meaning of the name, what's the meaning of the EQ, what's the meaning of the SAM single quoted.
Yeah.
And from the all node service from the Hassan's picture, all node service understand the meaning of the word name.
Yeah.
But it's based on the model. So from the model, you know, name is the word name is from the tokenized service. It understands there's a word tokenized. It's just to split the sentence into words using the white space split. So we can get name is a word, equal is a word, and we return the token array. And in the all node service, we take the all token array, and based on the model, we understand the name word is a property, and the SAM single quoted is a constant. So the output of the all node service is the all node instance.
Yep. All node root.
Yeah, so it's different. So tokenize only understands the words, do the lecture, and the all node service based on the model to understand the words from the tokenized service.
And the other thing is at the tokenization level, we want to capture the white space as well to make sure literally every character is captured.
Why do you care about the white space?
Because further down the chain, you may care about it. We don't know what's going to care yet. But let's say, for example,
I thought that's the whole. Go ahead, Paul.
We might take the token array and we might decide that we're going to capture that alongside the O node when we build that. In, say, you know, earlier when we were talking about, you know, there might be some kind of concept of a query object that would encompass these things. And maybe the toString method on that, or, you know, get me the OData string method, whatever we want to call it at that point in time, just goes through and serializes all the tokens as an easy shortcut. I don't know. But it's worth capturing literally every character, because we don't know at this point what is going to be helpful versus what is not going to be helpful.
If the tokenization service can produce a proper type of every single word, including spaces, in a query, that would be a good job. But we need to name those somehow. We need to find a way to say I don't even care about naming them, but I don't want the tokenization service to end up being, oh, string split. That's not a business logic. There's no intelligence there. I'm sorry, go ahead, Sam. You were going to say something.
How does it know the type from the string?
That's what Paul is arguing for. He's basically saying I don't want it to know the convention, and that's fair. So if I go into
No. What I'm saying is there some level of convention here that we do know versus some level that we don't know? Yeah. So do we know that EQ is an operand? Can we say that as a rule at the tokenization level without knowing too much about the structure? So if I see a word and it literally contains EQ and nothing else, then I can say, hey, that word is an operand word, versus say, if I had $EQ, I might infer actually that's a parameter.
It's the same thing. So maybe we can have a property name EQ. So you can do like a dollar filter EQ and EQ Sam, something like this.
like how, Sam?
So you can say dollar filter.
Dollar
You
filter.
can add a new line. Dollar filter symbol EQ and the EQ.
Like this?
What space? EQ. Anything.
You can do this
single quote. So
yeah,
it allows to build a property name with EQ. The property name is EQ. It's also it's valid. So okay.
How do you what's your guys' definition of token in the first place? What's a token to you, Paul?
So my thinking is that the way that we read the query as a human is broken down into key pieces that we're recognizing here. So
yep.
This list of items that you've got, parameter, constants, properties, operands, we intuitively look at that and we say, hey, this is the list of stuff that's in that query, right?
Mm-hmm.
So if I was to tokenize, if you like, this query, what I'd expect is essentially an array of, for lack of a better expression, let's call them O tokens.
Mm-hmm.
And every O token would have a type and a value. And only that. And it would just be a flat list. And my thinking is then from an array of tokens, I should be able to build a hierarchical O node by parsing them in the order that I've received them. But if I took that flat list of O tokens, and if I took the value property,
if you ignored the open close parentheses, it will freak out. It'll say, I don't know if this is at the same level or is a child or what is it. I see what you're saying. Yeah.
Yes, but if I took that flat list of O tokens and I took the value off of every O token, ignored the type, and just strung them all together, I should get the original query that I started off with.
That's right. That's the point. That's why we're starting with the token and we need to work our way back into a query. And out of that query, we're supposed to produce the same thing. That's how you know, right? So a thought that just hit me while you guys were talking about this. If I go back to the black screen here, what do you think about this? Imagine that this is your tokenization service. And your tokenization service is sending a message out there that's saying, let's say you have operands service, you have property service, or whatever the case may be, and it's sending that query out and it's inquiring from these services, multiple services, how to define these things. This way you're allowing engineers to come in and say, even though this operand service only defines EQ and, greater than, we can also include another service in here that says operands service 2 that will include XOR, and this guy will be none the wiser because it's sending out the request and it's saying which one of those is an operand. Who can come back and tell me, what the definition of these tokens are, so I can set up a type for them. What do you think about that?
Yeah, I mean, this is why I was saying earlier that if from a tokenization point of view, there was a list of known operands, it would
But we
need
don't
to
want to
be
define
something.
these operands in the service itself.
Can we go
No.
back to the example we just had with the OData query up?
Yeah.
I was going to say, like, maybe it's a constructor parameter or something to the operand service that you give it the list of known operands or something. So from an overriding point of view, or DI or something, you could just pass in more or less values. But
I
then
like that.
calling it, say, without that parameter passed into the constructor, it would run the default constructor, which would provide the default list.
I like that, Paul. This is perfect. I love that. You can go and say the default constructor for the tokenization service, right, is having an existing list of, this dot known operands. And these known operands is whatever you want to define them to be, right? So these can be the EQ, whatever, or you could have another constructor in here that says, okay, you don't like that, give me the list. But does that append or override?
I would be inclined to say you'd
Like,
have.
are you adding to the existing ones?
Yeah, I mean, you could either have like a Boolean optional extra parameter that defaults to a known value. That would make it clear, if you like, whether or not you were replacing or adding. Or you could just document it such that it says, hey, it does this. So you could say, okay, I'm going to document it so that it does a replace. But if you want the default list, here's how you get them. And maybe they're exposed as a public static property of tokenization service or something.
You can still offload that by passing in another service into this guy.
Oh.
And then you can have composite services that get it from wherever you want.
Yeah. Are you then overcomplicating it though? I mean, it's just
yeah.
a
I was
string
just
list,
gonna,
right?
yeah.
Aren't we?
I mean, I know that Hassan is a big fan of having lots of like micro services, for lack of a better expression. I know.
What are you talking about? I build
a test.
I build everything in one file. Everything. I put everything in one file, and that's your entire application.
Is that the service?
The original console app.
Okay, listen, guys. I just to bring the focus back on this, I think what Paul was talking about is pretty cool. He's basically saying, don't even give them types. Just break them apart into smaller tokens. So your token list would be something like, here's a token, this is a token, and the value of it. We could add other things to it, but this is the value of it, and the value of it is a filter. And here's another token in here, and the value of it would be, I'm assuming even the equal sign you're gonna include, Paul, right?
Sorry, that wasn't what I was saying. I was saying that tokens would still have a type.
Sure. But you're still
level...
honoring every single bit on the query, right?
Yeah, so
Okay.
we would still capture, so like when you get to the white space, you would capture the white space characters, and those would be your value.
Yeah, what's up, Sam?
Yeah.
So this would be like that.
Something.
And then Sam, stay with me. This is important. What? What is this guy doing? Sam, are you still there?
No, go ahead. Why do we need... Hi, I'm here.
Why does it seem like you're talking to someone else? Huh? Since you got popular, I can't talk to you anymore. Huh? I'm like your
what I'm thinking is, can you hear me?
Yeah, I can hear you now. Like this, Paul? Is that what you're saying?
Yeah.
I would probably go a step further as well and actually say, hey, the single quote is its own token.
Whoa.
Because then you could denote with convention, you could say, hey, if I have single quote, some word, and then another single quote, I can define that as being a string convention, as a string parameter somewhere, as opposed to if I just have a value, it might not necessarily be a string. So, for example, there are situations where I can have a string of characters that are not strings, but they're complex types like date times or enum values in my URL. And that's perfectly valid, but those are still value types.
Really?
So, yeah, it's one of these things where, like, at this level, from a tokenization point of view, bear in mind here, I'm gleaning all of this insight from stuff I read from what Sam wrote.
Uh-huh.
And I believe that, you know, this is a solved problem, what we're trying to achieve here already. And I think that the solution that's already in the framework is a pretty good one. What we're essentially doing is rebuilding that same solution, but we need to be smart about, you know, thinking ahead and saying, hey, what does a literal mean versus, you know, like a string literal versus an integer literal?
Because you want to allow people at some point in time to go and say, oh, this here is a new form of tokens for someone who wants to build a query that is looking like this: compute equal, you know, age bigger than 100, or even
I mean, what if somebody wants to support link expressions, for example, in the URL? I mean,
no, I see what you're
right?
saying. I see what you're saying, Paul. I think it's
yeah.
pretty
So
cool.
we need to be very careful about kind of like what represents, and think about it from a programming, or, you know, sort of like what the Roslyn team would think about this from. Think of it as a string of code rather than as a string of data, and then be like, hey, okay, if I was parsing this from a code point of view, and I'd have to feed these instructions into something far lower level, you know, I'm building, say, assembly from it, or, you know, the raw binary to chuck at a CPU. What are the key bits of information that I need to break out? And then once I've broke those bits of information out, what is it that I need to produce from each of those bits? And actually, if you look at that kind of flow of tokens that you've got there, if you look at the last three in particular, if you took those two single quotes out and just had the center one, that could mean something completely different.
I agree.
Yeah. So, and again, this is all information I kind of gleaned from the existing OData implementation and from playing with OData queries myself, you know, in my own code. Just from tinkering with OData queries and sort of understanding some of the capabilities of the existing OData sort of standard, if you like, you can get an idea of the sorts of things that perhaps so far, particularly with O nodes, there might have been a certain amount of oversight, or well, there definitely was a certain amount of oversight in the way that we were kind of breaking things out. Whereas this level is kind of like a level lower. It's a predecessor to building out O nodes. So it gives us that opportunity to be extremely precise.
It's like the assembly level of OData queries. You're going very okay, and I agree with that. I think it's power, but let's move this conversation forward. What were you saying about the types on these? I don't want to put types on these, not at the tokenization level. I just want to know what the team thinks about that. Go ahead, Paul.
I think we should put types on them, but these types might not necessarily be the same types as the O node types.
So what kind of types were you thinking?
I agree with Paul. They should be token types, and they're very explicit.
Like what? What do you call them? Like literal?
Well, later on, I'm not sure. The quotes, you could do constant leaf or something like that, or the single quote. So that denotes either the beginning or the end of a constant. So it does have a particular focus when we go to process this later. So we can give it a type real easily.
Just to wrap up, because we have only 10 minutes, I need the team to think about names for these types. I'm okay with this approach. I think it's okay. I think it's pretty genius, actually. You know, um, I think if you, I think if we can come up with precise names for these token types, we can make it a lot easier for the O-Node service or any service that is feeding on O tokens to be able to easily process these types. But I need names. We need to know what these names are. What are you going to call these types? And think really long and hard about this until Friday, because I want us to move forward, you guys. I want to put something out there, right? And I don't really care about when we're going to be done. I just want us to keep going forward. Otherwise, we're just going to turn into one of these podcasts where they talk and talk and talk and they never get anything done, right? Let's not be that. Let's take this and implement it. I think the O token approach makes it that the other aspect, Paul, that I like about this is that it makes it a lot easier for someone who's trying to contribute to our project to understand what the heck is going on, because you're breaking things down to a very granular level that will make it very easy for them to go and say, okay, I want to introduce a new type of token into the system. What's that going to look like? Let's agree on the naming conventions and the types. Feel free to engage. Sam, join, put some stuff in our Discord channel in terms of typing. If you can think of, few names for types, what kind of types we need to have. We're thinking constants, we're thinking string literal, we're thinking, operands, operators. Don't worry about the abstraction of it yet. Let's just come up with the end goal of the tokenization service, and let's pick it up from there. Does that sound like a plan? Yes? No?
It's
Sam's
a
the man
plan.
on
So I
this.
agree with you, but I have some
Go ahead, Sam.
input. You
Go
you
ahead, Sam.
killed me a lot. Sorry, there's some noise from
Oh,
my.
no worries. Go ahead.
So one so what's our put? I mean, we want to output the O node.
O
O
token.
token is internal. We don't need the customer to understand the O node structure, right? Or not O node, or O token. So O node is our output, and O token is our intermediate output. It helps us to build the O node easily.
No, no, wait, Sam. On the tokenization service?
Yeah, it's output the O token.
Yes. Stay here.
And
Yes.
yes, this is not our final goal. Our
It's
final goal
not.
is the O node.
The final goal is actually whatever gets translated out of O node.
Yeah, it's O
Well,
node.
question though, because this whole process has gotten me thinking, right?
Yeah.
Thinking about the lake house and further down, and thinking about what we were talking about services and conventions.
Yes.
If you had a convention that defined a particular set of tokens and said, I handle that set, you could effectively process straight off of your token list. You wouldn't necessarily need a
Yeah.
model.
If you want, O node is just for. Here's the thing. The whole idea of the lake house is to say, if you want to use O node, great. But if you want to subscribe to that event and produce your own values out of token directly, great too. Again, it's extreme separation. Like you're really taking dependency injection to the next level. You're just subscribing to this event that's shooting events at you, and the ones that you really care about, what you will receive, and the ones that did I show you guys the POC for the lake house? Did I show any of you none of that? What the heck? What am I doing? Are we just joking and laughing all day? And
We've already fired you twice, and
The
you're still
overall
here.
concept, an event-based pipeline.
yeah.
Yeah. Okay.
So you're basically a bunch of services that subscribe to that event-based pipeline, and it's saying I care about events with these particular types.
Yeah.
And when these events occur, your service lights up. Right? It does some work and then it either sends something back into that event bus, or it just says I'm done. I produce something and I'm done. I don't need to do anything else. Right? I would wonder why you're not producing anything back in the pipeline. Think of it as if you're in a kitchen, right? And someone says we need the salad and they're tossing a plate. Someone is cutting the onion, someone else is cutting the tomatoes, and someone else is cutting the lettuce. And then all of that gets put into the plate, and the plate gets shipped back into the service. The intelligence of the Lakehouse here is that the Lakehouse knows how many subscribers are to that event, so it won't give you back the response until all of these guys are done. That's the magic of it, right?
Yeah,
Someone someone
I understand it.
someone chewed me alive on a public forum the other day, and he said, "Listen, man, I don't care about your custom implementation." I'm like, "Okay, what's out there that can do that?" And that's when he froze. Like, people, it's very easy to put on our judgy pants, but when it comes to implementation, that's different. Anyway, we interrupted Sam. Go ahead, Sam. You were saying. I'm
Yeah, I
sorry,
just
Paul.
finished the first one. So second one, so maybe next time we need to draft the interface definition for each service. So I'd like to understand from the top to the bottom, from the left to the right.
But don't go write code without a session, though.
No, it's not the real code. It's just interface definition.
No,
So
I know.
which one is the input and which one is the output for each service. For example, the field service in your Lakehouse. Okay, the field service is take the O node,
It will
right?
take O node. It will
And
take
what's
O
the
node.
output?
It will produce from the other side. In our case, for OData default implementation, we're producing an expression.
Yes, it's an include expression. So
But
how customer
anybody,
can override it? How customer can customize it?
yes.
So that's our goal. So
wait.
this is the interface definition. Customer cannot override the definition for the interface.
There is no interface. You're just subscribing to an event, and you're saying when that event happens, I will take that data and okay, in a way, see, you're thinking interface because you're thinking classic dependency injection. I'm saying the only thing you need to care about is the contract of the event that you will receive. That's it.
Okay,
you
so
don't need to implement interfaces.
So we public event handle, so customer can subscribe that event, right? If customer subscribes the event, we will call the event. But the event has the interface. Is what's the interface for the event?
Yeah, I agree.
How's the contract? Yes, a contract.
The contract.
What's the contract?
What's that contract?
It's on the event itself.
The event has an object within it, and that object is whatever. Like, if you say, I want to subscribe to filter queries, so that's an event of type filter query, and it has a dynamic object in it, and you serialize that and work with it however you want to work with it.
It's an in-process message broker, or kind of like in-process webhooks. So something happens and you get a payload, and based on the event, you can expect it to have a certain shape.
So instead of one Sandra Bullock waiting for one Keanu Reeves, think bunch of Sandra Bullocks waiting for a whole bunch of Keanu Reeves in the other side. If you watch the Lakehouse movie. If you didn't, then that's mandatory, guys. It's work. Come on. Look alive. So
what based off from?
Yeah, that's what I based it on. The Lakehouse, that Sandra Bullock. It's stolen
A
from
time traveling mailbox?
Yeah.
Okay.
Did you see the movie? You did, didn't you?
What's the movie name?
It's called The Lakehouse. Sam, watch the original one. The American one, they butchered the nice Korean one. There's a Korean one, there's an American one.
I'll have to watch that. Yeah.
And they just broke my heart at the end when he said, "Oh, sorry, my brother died 2 years ago." Just the look on Sandra Bullock's face when he made that. That's why she's a great actress. She can make that face expression. But watch the movie. It's really important. They're leaving messages for each other, and then the box just goes back up from 2006, I think, Joe, 2006, and then
yeah. So that's
what I named it after.
This is based off from is Bistromatics from Hitchhiker's Guide to the Galaxy.
Oh, I love. Do you know? You're joking. You're talking about.
Oh, I'm serious.
You know what you just said. It's very interesting because I have this guy.
Oh, I got a hard copy. Yeah.
So that's the hard copy, and I also have this. Hold on, let me show you. I have also the one I like is this guy. Nope, not this guy. This guy. This is
that's a dumb book.
Can you guys read it?
I don't know that one.
It's because it's in Turkish.
It's
the I don't know that one.
It's the Hitchhiker's Guide to the Galaxy. But anyway, yeah, I see what you guys are saying. So anyway, regardless of where the name is coming from, I think it's a pretty nice movie, and I like rom-com anyway. But you know, the what you're saying, Sam, is right. You know, we want to subscribe to an event, and the event is giving us a payload, like an object, right? But you're thinking way down the line, and I'm okay with that. You know, I just want you to still think like fog of war. We're just kind of exploring as we go.
So
Right.
this event here would have a string input, and it would expect that this portion of the Lakehouse would return
some expression.
Yeah,
Mm-hmm.
So we should
what
test
I'm
that.
thinking
A
is
given string equals a given token array.
Yes. Go ahead.
Yeah,
Sam.
what I'm thinking is we have to the first one we have to build the structure of the house, lake house. Then the second one is we have to decorate the house. But now we try to decorate the house, but that house is not exist.
But wait, that Lakehouse Pattern is just a transportation mechanism. It doesn't matter.
I try to understand that.
I'm just trying to build the parts that actually make the function work, and whether we want to do the classic dependency injection or just use the Lakehouse, that's fine. Either way is fine.
We need to build the structure of the flow, and
Yes.
we can dig into each part and finish each part, finish each implementation. So that's what I mean decorate.
Yes.
Okay.
Like I'm not completely sold on this Lakehouse thing yet, but
we'll see. Listen, I've never done it before. This is why I'm putting myself out of my comfort zone and saying, okay, based on what I learned about dependency injection, if you're doing everything the exact same way you were doing it last year, you're not growing. You'll end up like these folks that say COBOL is the best programming language. Do you want to be that guy? Is that who you want to be, Paul?
Well, I thought Fortran was better.
Just nonsense.
Yeah, that's why I'm here. I try to learn from all of you.
So there is this little thing I call it the software engineering manifesto. Please read it. If your code today is exactly the same as your code a month ago, you're not growing. You're moving data around.
Yeah, I agree.
Okay, but I'm using existing knowledge that I have to propose a new solution. And like, you know, someone yesterday posted this on LinkedIn. He said to me, "Where did you come up with this cul-de-sac pattern?" I said, "I invented it." He's like, "Well, there's no research about it." I said, "How do you think everything we have today came to be?" Someone just put it out there and they saw whether it's valid or not. It's exactly the same thing that I'm doing here. My title says innovator for a reason. I invent shit. So keep that in mind, you know? Anyway, you know, let's come up with names for these tokens, Sam. Paul, Joe, please, guys. We need names. We need names for these token types. Please engage in our Discord channel. For the people watching us, please join us in our Discord channel to understand these types. This is the real deal, the real life scenario. Remember the first session I said, oh, we're probably going to come back and rewrite all of this, and that's okay. That's the point of this process, for us to make mistakes, fail fast, fail cheap, fail soon, and reiterate.
So I'm thinking the obvious way to approach this is to think, like, for a given token type that you want to define, think of what the business rule would be. It should be a single, very simple kind of statement that you could make.
It needs to be generic, really generic.
So we could say something like, you know, an equals token is exactly and only equal to an equal sign, nothing else. And so if you've got that, you can say, hey, that represents an equals token. And so it's very easy to test for then as well.
Come up with a list on Friday. Okay? Friday. Come up with a list. By the way, I can't say Friday anymore. I have to say Friday.
You ruined it with one guy.
So, okay, guys, I appreciate you all. And for the people watching us, you know, as usual, you know, I really enjoy these discussions, and I'm sorry for the little delay. If you have any questions, comments, concerns, compliments for Paul and Joe and Sam, please feel free to drop comment in the comment section. As usual, don't forget to like and subscribe. See you guys in another video.
It was his fault. Whatever it was, whatever the complaint, it was his fault.
It was his fault. I'll talk to you guys later. Take care.